Physics at Portland Community College, and he's also the Director of Academics and Research for the Juneau Icefield Research Program. Since 1946, the Juneau Icefield Research Program has conducted long-term research on the interrelationships of Earth systems disciplines to understand the total environment and resource potentials of Arctic and mountain regions. So for 2 months every summer, 40 to 60 students, professors, and research scientists participate in the Institute's programs. And Toby is also an inventor with over 30 patents. Yes.
Yeah, I figured that was. Started with C. Yes. Oh, let's see, scale. I start every day in my classes with the astronomy picture of the day. And if we have about 1 minute for this, today's is a really interesting thing, which I think is important because science is all about observation, and the interaction between science and humanities comes from the fact of great observation. This happens to be the moon, Phobos, and this crater here is the Stickney Crater, which is on the Martian moon Phobos, named after Chloe Stickney, and it was discovered in 1877. And this balloon is only 18 kilometers in diameter, so it's a very tiny gravity field. And my students were excited to know that if you had something and you dropped it, instead of accelerating at 10 meters per second squared, like here, it would accelerate at 1 centimeter per second every second. So after 3 seconds, it would move kind of like this, very slowly from the gravity on Phobos. But does anyone observe something unusual here? They're talking about these rocks sliding down the cliffs. It's an exercise in observation. And like on the Juneau Icefield, we train students to observe and to see as opposed to just looking. Well, how steep is that cliff compared to, right here, compared to on Earth? I mean, could you tell the difference between that cliff on Earth or that cliff or a cliff on Earth? Doesn't that seem odd that if it was very low acceleration of gravity, that it wouldn't be steeper because it would be harder to get something to go downhill? Well, the fact is, I just realized this a while back, if weight is down and pulling it downhill, and the force from the surface is uphill, which creates friction, perpendicular to this hill, and which creates friction, which is uphill. So if you reduce weight, you reduce the surface force, which reduces friction in proportion. So it turns out that the slope of a cliff is irrespective of the acceleration of gravity. Cliffs on asteroids are the same steepness as cliffs on Earth. But that is just a feature of it's just an interesting fact, and I always have fun with my students. Duncan is a videographer. He was our videographer on the Juneau Icefield, and he is putting out next month his 44th PBS special on Ronald Reagan, and he produced this short promotional video on the Juneau Icefield. are the waves on the glacier that I first studied.
There's something magical about being up here. Never been any place like this in my life. It just reaches down and touches you deep inside.
This is the most wild place I've ever seen. There's no people up here except for us, and it's totally untouched, which is pretty cool.
Come out here and you realize how absolutely seemingly insignificant you are on a personal level. I mean, you learn a lot about yourself when you're out here. It's books, nature, and action.
Europe is very, I mean, it's just such an awesome program because besides the science part, you have the expedition part where just your interaction with other humans and the interaction with the mountain and glaciers.
That's me
I
driving.
definitely learn a lot about the field work involved in glaciers and their importance as far as like studying climate change and effects of climate change and the ecosystem.
We make all students do projects. Usually they're associated with our surveying, our mass balance, our glaciological, geological, and botanical studies.
The science is like the icing on the cake up here.
It's interesting to be learning about how much glaciers influence the world.
Well, the mass balance part of GERB is one of the most important for the long-term measurements that GERB has established. Since 1946, they've measured mass balance.
We can find the overall amount of water that is retained in this body of ice over the last year. That's called the total mass balance of the glacier. We've studied this now for 65 years on this very responsive system, and so we have a very long record of mass balance, which is telling us what's happening on this system as a result of climate change.
The main thing I've learned here is that you have to risk going too far in order to see what your limits truly are. Like you'll never know what they are if you don't try.
I love being outside. I love climbing mountains. I love skiing, and I love geology. And how much better can it get than a place like this?
It was just an awesome experience. It's probably the best experience of my life. So it really does it for the program for the students. The students they just leave a mark on you and you leave a mark on them.
That's the mighty Taku Glacier, 4 miles wide and about 20 to 30 miles long. And this is our website if you feel like visiting the website, our Facebook page, or Twitter. But I want to thank you for having me come down here and talk about the Juneau Icefield Research Program. I've often felt that us scientists who study climate change don't do a good enough job to relate to the humanities, and so what attracted me was the idea that this is, to interact with the humanities and spread some information about our work. I did, in that vein, think that it's more a responsibility to relate climate change to the world and as a whole, and the public as well. And so I wrote this article here, which I recently submitted to the New York Times. I don't know if they'll publish it, but I'm hoping. And it focuses on the problem of climate change and the results of one of our scientists, Ben Santer, who is a world famous climatologist, one of the most famous in the world, who has recently published an article that scientifically proves the human influence on climate. And so I'm going to pass this around, and if you want to get this, if you want me to email a copy of this article to you to read about his work and the other points, then just put your email on the back of this, and I'll make sure that I email you that thing. My name is Toby Dietrich. I teach physics at PCC. and work on the Juneau Icefield starting in 1970. I think I've changed a little bit since 1970, I think. And the Foundation for Glacial and Environmental Research is the nonprofit that operates the Juneau Icefield Research Program. And here I was surveying with theodolites the movement of the Taku Glacier in 1970 as a student. I wouldn't be a faculty member today if it wasn't for JER. Our founder, Dr. Maynard M. Miller, was the scientist on the American Everest expedition, and took Robert Kennedy to the summit of Mount Kennedy and mapped Mount Kennedy massif. And he's done amazing things, but about 10 years ago, he became too old. He crossed the ice field 65 times, and he was about 88 years old or 85 years old, and he just couldn't do it anymore. So Scott McGee from Fish and Wildlife in Alaska and I took over running the program, and now we have a new director, Jeff Kavanaugh from University of Alberta, that is operating the program as director. What is the effect of climate on glaciers? You don't have to guess that. The climate is melting the glaciers, and this is measured by mass balance, and you saw us measuring the mass balance in the film. The mass balance of the North Cascades Glacier since 1984 is dropping. The world inventory, total ice, glacial ice in the world is dropping dramatically. And Dr. Maury Pelto, one of our faculty members, is a world expert on measuring this and putting publications out on the mass balance of glaciers. He does our work. What is the best way to get an idea of the melting of glaciers around the world is through the GRACE satellite, one of the many satellites in the constellation that the United States operates that monitors satellites. And these two satellites measure the acceleration of gravity. And they do it by measuring the distance between the two satellites flying in formation. It's really an incredible tool because it can measure the changes in gravity and then in turn relate that to the lowering of the ice, or equivalently the mass balance of the world all at once. And so it's a real amazing thing. And what you find from this result, measured in centimeters of water equivalent per year, meaning blue -5 centimeters and red +5 centimeters, that the majority of the melting is in the northern portion, Greenland and the North Sea area, northern Canada. But if you look at the blue there, right along the Alaskan coastline, right in this area here, you see that a significant amount of melting is occurring along the Alaskan coast, particularly up by Anchorage, between Anchorage and Juneau, in the massive amounts of ice in that area. The Juneau Icefield is a very tiny ice field compared to those areas. It's the 5th largest in North America. But we're very close to Juneau, so it's a very convenient place to study and supply with helicopters. So the majority of this water that's coming off of meltwater is coming from the major ice fields here along Glacier Bay. And this is some really impressive country if you ever get a chance to go up there on a boat or fly over in an airplane. It's really impressive to see. And the glaciers in this area are melting very rapidly. A lot of them are tidal glaciers that go out into the ocean, some of them floating, but most of them have melted off the water now and up are land-bound. But for example, the Columbia Glacier, which one of our faculty members is the lead scientist on measuring that. He was a graduate of our program and then went on to PhD, and now he's a faculty member who is the world expert on the Columbia Glacier. And that glacier is absolutely retreating. It retreats about more than a mile a year. And they time-lapse it and they fly it over it with LiDAR measurements, and it's the most studied glacier in the entire world, and it is just completely retreating. The Juneau Icefield lies right here. There's Juneau right here, and this is the Juneau Icefield spanning from Juneau to Skagway. It's about 1,000 square miles of ice, and we'll see another view of it there, but that's the chunk of ice that we do our research on. There is a artist view of the Juneau Icefield. Our students land at the Juneau Airport right here, and then hike up just directly from the Costco parking lot, and hike up this ridge here to up right in here. This is the Ptarmigan Glacier and the Lemon Creek Glacier right here, right looking down onto the city of Juneau. And this is where in the International Geophysical Year, they started 8 prototype glaciers in the world to start monitoring them in 1958, and we've been monitoring that glacier ever since. Then the students hike and climb up over Nugget Peak into Death Valley, across Death Valley, up the Norris Icefall, and then right here under the southwest branch of the Taku Glacier, camp right here overnight, ski all the way up here to Camp 10, and spend a couple weeks there. We do and more rapidly at higher elevations, and the diversity of vegetation has rapidly increased. But I would like to just end with one thought. You might think that because the plants are growing, that climate change is good for plants. The exact opposite is true. Climate change is terrible for plants. This is pioneering plants in the land that's been deglaciated. For every 1 degree, as I say, as it points out in my essay with the lectures to back it up, for every 1 degree C temperature change in the world, the production of the 5 grains that feed the world decreased by 10%. So if we look at 3 degree temperature change by mid-century and 5 degrees by the end of the century, possibly, we're looking at a world that has 50% more people and 30 to 50% less food. Right now we have 2 billion people that are food threatened, so it looks like we will have possibly 9 billion people, half of which 5 billion people will be food threatened towards the end of the century. And this, to me, is the #1 problem of climate change, the #1 effect of climate change on humanities, is how do we supply food with decreased river flow and increased temperatures. So that's it for me.